In this video, we're going to be looking at using completing the square to find turning points of a graph. Please make sure that you've watched my previous completing the square video before you watch this one. Here we go. So, y equals x squared plus 2x plus 5, well that's a quadratic graph. I know this because the highest power of x is a square. Now, let's start looking at the y equals x squared graph. So this is our standard y equals x squared graph. Okay, and that graph there is coming down, it's coming down until it gets completely horizontal down here at the bottom and then starts going back up again. We call this point here a turning point because it's coming down and it's going back up again, so it's changed direction. In this graph, that turning point is 0, 0, the origin. Now the problem with our graph is we do not know where that turning point is because this quadratic graph has actually moved left, right, up, down. We don't actually know where it is at the moment. Now, the problem with this graph is, in its current state, it's very hard to tell where that graph has moved to. However, if we write it in its completed square form, it's very, very easy. So I'm just going to do the completed square form for this bit. So it actually comes out at x plus 1 all squared plus 4. They are essentially the same thing. Okay, so when it's in this form, there are two things that I'm looking for. Now, it actually links into transformations of graphs, but I'm not going to go into too much detail with that. I'm actually going to show you what we're looking for. I'm actually interested in this number here, and I'm interested in this number here. They're going to make up my minimum point. So my minimum point, or my turning point, is going to be the opposite of this value. So positive 1, obviously, is going to be negative 1, and the actual value of this one, so 4. So I now know that this x squared graph has actually moved minus 1 and then up 4. And again, it's going to look something like this. Okay, so that is how we find a new minimum point by using completing the square. Let's try another one. So this time I'm going to have to complete the square. So how to get that value, I need to do an x plus half the value of 8 is 4, all squared. Now, if I did expand those two brackets, I would get x squared. I would get double that value, which is 8x, and I would get square that value, which is positive 16. Now, I like the x squared, I like the 8x, but we do not like the positive 16. So I'm going to do that again, but this time I'm going to put x plus 4 all squared. We need to get rid of this positive 16, so let's take away 16, but we've also got a positive 6 over here. Right, we're almost there, so my answer should be x plus 4 all squared, minus 16 plus the 6 is actually minus 10. So now from here I can write down my minimum point because I know it's going to be the opposite of this value, which is negative 4, and it's going to be the actual value of this one, which is negative 10. So this graph was at 0, 0, but it's now gone negative 4, 1, 2, 3, 4, and then gone down 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this graph would do something like that. Okay, next one. So again, we need to complete the square. So to get those two values, I'm going to have to half the 6. So x positive 3 all squared. If that expanded, that would give me x squared. It would give me double that value, which is positive 6x. And it would also give me squaring 3 would be positive 9. I like that. I like that. We want to get rid of this positive 9. So x plus 3 all squared, get rid of the positive 9. We've still got a minus 4 over here, so let's tidy this up a little bit. We've now got x plus 3 all squared, minus 9, take away another 4 is actually negative 13. My minimum point for this graph is going to be the opposite of this value, minus 3, and the actual value of this one, so minus 13. So it's actually going to go 1, 2, 3 backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there is going to be the turning point in this graph. Bit of a bad diagram that one, so I'll probably do that one again. Okay, so down here. Right, let's try another one. So completing the square again. So to get those two, I'm going to do x minus 6 this time. Remember, it's half of that minus 12, all squared. that would give me x squared, double that value, which is minus 12x, so that bit's correct. But if I square negative 6, remember negative 6 times by negative 6 is positive 36. I like that, I like that, I don't like this. Let's get rid of it. So I'm going to still have x minus 6 all squared. I'm going to get rid of this positive 36 by taking it away. And we've also got a minus 6 still left in the question. So my answer will be x minus 6 all squared. Minus 36, take away another 6 is minus 42. So my minimum point for this question is going to be the opposite of this value. So that'll make it a positive 6 and the exact value of this one, minus 42. And that's all we're looking to do. What about this one? So this time we've got x, half of 10 is 5, so all squared. That would give us x squared. Double it would be minus 10x. Square minus 5 is positive 25. We like that, we like that, we don't like that. So let's go with x minus 5 all squared. Get rid of the positive 25, so minus 25, and we're going to add 9 to it. So that'll give me x minus 5 all squared, and that will give us minus 16. So my minimum value will be the opposite value of this, which is positive 5, and the exact value of that one, negative 16. There is our minimum point for that question. Okay, so this is the time where you give it a go. Pause the video here. The top row ones are fairly straightforward, then the middle ones are a little bit crazier, and the bottom ones are supposed to be a little bit testing. Have a go at them all. Pause the video here, and the answers will be on the page very shortly. Okay, here come the answers. Give them a tick, give them a cross. Hopefully you got them all right, and that is how you find turning points by using completing the square. Thanks for watching the video. I hope you've learned something.